Hello and welcome to another tutorial. We are looking at the switch expression, and now we're going to look at the producing a value. This switch statement can be used as an expression, and we saw that previously we had this example of the conventional switch statement, and then we can translate it into switch expression using the arrow operator and the comma separation for multiple labels. For instance, the example of the previous section can be rewritten with the switch statement in the following way. So we switch, and then remember after that after the switch expression we have to have a semicolon, because the switch and the assignment operator and the left hand side, these form one single statement, and any statement in Java has to be terminated by a semicolon. So we switch on a string, we switch actually on an int, which is an allowed type for switch, and then case 0, 1, 2, 3, and then the arrow operator, right? And then we return a value and we terminate with semicolon. So this is the most concise way, and it's best to have also a default. If we don't add a default, the compiler is going to complain, because then if none of these cases match, it's not clear to the compiler what value is going to be returned. So switch expression is guaranteed to return something, so we have to have a default there. If there is only one statement in the case block, the value produced by this statement is returned by the switch expression. So if we only have one line of code for the body of each case, then we use the arrow operator and then the value that we're going to return. Now what happens if we have multiple lines? So the syntax in the case of a block of code is a little different, and we already saw that. After the arrow operator we have to use a basically pair of curly brackets to define a body of codes, multiple lines or multiple statements for a given case. But then the question was, how do we return the value after multiple lines of code for the case, right? And we cannot really use the return keyword because it's reserved for returning out of a method call, right? Traditionally, the return keyword is used to denote the value produced by a block of code, and and that block of code has a name, right? A method. So a method is a block of code conventionally or traditionally, which it does some stuff. It has multiple lines of code or statements, and then eventually returns something. Unfortunately, this syntax leads to ambiguity in the case of a switch statement when we try to convert it to switch expression, right? Let us consider the following example. This code does not compile. It is just there as an example. Now we have this method. It takes a quarter, right? And then we are assigning using a switch expression. So this is our switch, and it has one case and a default case 0. It has a body for the case, so it doesn't have one line. It doesn't just tell it return this if case 0. We're going to have multiple statements, and then the question is, how do we return something from this case? Because the switch expression has to return something for each case and also the default. If if after the arrow operator we immediately write the value that we're going to return, then it's fine. But if we want to have multiple lines of code or multiple statements, then we have to open up a pair of curly braces, and we have to have this semicolon. We looked at this before, and then in the switch expression, and then we saw that we can create a body. We don't need to have this semicolon. I mean, we can have the semicolon. Actually it doesn't allow us to add the semicolon here, right? So after the body of the case, don't add, if you open a pair of curly braces, don't add a semicolon. You shouldn't be adding a semicolon. It doesn't compile, right? And but after each statement you should add semicolon. If you only returning value right after the arrow operator, you have to add a semicolon, otherwise it's not going to compile. So have these keep in mind. For example, this semicolon here is not correct, right? This code doesn't compile. Now the other thing is that we're using a return keyword to return a value from this case, and you probably can guess what happens. This actually returns from the method, and that's not what we want, right? So the return keyword doesn't work for switch statement that has multiple lines of code in one of the cases, right? The block of code executed in the case where quarter is equal to 0 right? When we hit this case, needs to return a value. It uses the return keyword to denote this value. If you take a close look at this code, you see that there are two return statements. One is here and one is here. So basically what happens here is that one in the case block and another one in the method block. This is where the ambiguity lies. One may be wondering, what is the semantics of the first return? Does it mean that the program exits the method with this value? And the answer is yes, the return keyword always does that. Or does it leave the switch statement? And the answer is no, the return keyword always jumps out of the method call. That's just the way the JVM handles the return keyword. Such ambiguities lead to poor readability and error-prone code. A new syntax has been created to solve this ambiguity, the yield statement. And we looked at this before, saying that the only thing that yield does in Java at the moment is that you only are allowed to use it in the body of a multi-line case for a switch expression, and it just tells the compiler, hey, we want to return this value and jump out of the switch. That's the only meaning of yield. Other programming languages have yield as a keyword, but with a different concept, like coroutines or generators. Java doesn't have those. The code of the previous example should be written in the following case. So now we are yielding. We have a multi-line case, and then we do some stuff, and now we want to return something from the switch, so we yield that value. We use the yield keyword. The yield statement is a statement that can be used in any case block of a switch statement. It comes with a value that becomes the value of the enclosing switch statement. All right, so this is the meaning of the yield. Adding a default class. We've seen that switch statements, switch expressions, it's best to have a default in case none of the cases match. And then with the switch expression, is kind of mandatory because the switch expression has to return something. So if none of the cases match, then the question is, if you don't have a default, then the compiler doesn't know what to do, right? So default clauses allow your code to handle cases where the selector value does not match any case constant. The cases of a switch expression must be exhaustive. So if, for example, it's good for enum because the compiler knows that the number of sets for the values case labels is limited, so the compiler either expects you to exhaust all the possible cases as case labels, or you have to have a default case so that the compiler knows what happens or what to do if none of the cases match. For all possible values, there must be a matching switch label. Switch statements are not required to be exhaustive. Now again, I want you to notice the difference. Switch expression must be exhaustive because the compiler has to know what value is going to be returned. Switch expression has to return a value, whereas the switch statement doesn't have to be exhaustive because it's not required to return a value. If the selector target does not match any switch label, this switch statement will not do anything. So right, silently. So if none of the cases match in a traditional switch statement, you just you just jump out of your switch. You don't do anything, right? This may be a place for bugs to hide in your application, something you want to avoid. In most of the cases, exhaustiveness can be achieved using a default case. However, in the case of an enum switch expression that covers all known constants, you do not need to add this default case. Again, if you use an enum, because enum is an allowed type for the switch expressions, right? And you can exhaust everything because the compiler knows how many different labels it's going to expect. If you don't exhaust all the cases, then the compiler enforces the fact that you have to add a default case, right, to a switch expression. There is still a case that needs to be dealt with. What would happen if someone adds an enumerated value in an enumeration but forget to update the switch statements on this enumeration? To handle this case, the compiler adds a default clause for you in the exhaustive switch statements. This default clause will never be executed in normal cases. It will be only if an enumerated value, like an enum type, has been added and will throw an incompatible class change error, right? So basically, you write a switch expression with the enum, but somebody goes and adds more values to that enum, right? Enumerated type. And then previously the compiler allowed you to compile your code because the compiler knew the enum. But then what happens if the enum changes? Now the compiler doesn't force you to basically update your switch statement. Instead, the compiler silently adds a default clause. Handling exhaustiveness is a feature of switch expression that is not provided by traditional switch statements, and that is used in other cases than switch on enumerated values. Now let's look at the other topic, writing colon case in switch expressions. A switch expression can also use a traditional case block with case label colon, right? And you can do that. We said that they introduced the arrow operator, so you don't need to write colon, right? But you can also do that, but then if you don't use the arrow operator, you are forced to use the yield keyword to tell the compiler what value you are returning, right? Because in the traditional sense, when you have this colon, the compiler realizes that, okay, it's more like similar to the traditional switch where none of the lines have any return, because the switch is not supposed to return anything, the traditional switch. But now you want to use the colon in the context of a switch expression, then you have to explicitly use the yield. Remember, the only use case of the yield keyword is for the switch expression. It tells the compiler, hey, for this particular case, I'm returning this value from switch expression, right? That's the meaning of the yield keyword. A switch expression can also use a traditional case block with the case L. L means label, colon. In this case, the fall-through semantics does apply. So it still works. In order to avoid that, you kind of need to yield. Values are yielded using the yield statement. So case 0, you yield, you avoid the fall through using yield. And you don't need to really use a break. And we can test it. So let's create another method here. Public static void. So let's correct this. Public is a test3, and in the main we're going to invoke test3, and let's just copy and paste this. Okay, let's say quarter is I don't know, 1, and then eventually after the switch expression we're going to print the quarter label. All right, so this is what we have, and then if we run this, we're going to get Q2, right? And yield. What if we don't write yield? Then what happens? Then we get a compilation error, insert assignment upper, so the compiler doesn't understand what's going on. And can we mix and match the colon and the arrow operator notation? The answer is no. Mixing of different kinds of case statement, arrow and colon, is not allowed within a switch. So at the moment they're not allowing you to mix basically the arrow operator notation and the colon notation. You have to only choose one of them in the context of a switch expression. As you can see, the compiler is giving us a compilation error saying that mixing of different kinds of case statements, basically the arrow operator, the arrow notation, and then the colon, is not allowed within a switch. They have to say a switch expression, because obviously in the switch statement you are not allowed to use arrow operator. The only choice is colon, and in the traditional switch statement you are not allowed to use yield. So we only use yield in the context of the switch expression. So again, colon and then yield. It doesn't have to be obviously for here we need to use the yield keyword, and it doesn't have to be on the same line. We can just put them on the other line, which is a little bit more readable to me. But some people prefer to, if you have one line of code, you want to immediately return some value from your switch expression, you can put them on the same line. And we saw that we can also always have a body, right, for our case. That's it doesn't give us any compilation error. It still works fine if I set the quarter to 0, for example, and Q1. So the pair of curly braces is not necessary. What happens if we as you can see, the fall through doesn't happen because yield immediately returns when when JVM basically hits the yield keyword, it immediately returns from the switch statement, right? So we don't really need to have a break. What if we add the break intentionally? It doesn't give us a compilation error. And the answer is yes, it's giving us a compilation error. And we've seen this kind of error before. Java compiler doesn't allow you to have a code that is not reachable. So the compiler immediately realizes that when it hits the yield, it jumps out of the switch, right? And we assign this value to this variable and move on. So this line of code never reaches. So I mean, obviously it doesn't hurt to have the break here, but it never reaches, and the Java compiler doesn't allow you to have unreachable code, right? That's why you get that error. What if we want to say that var x1 equals this? And note that what happens here, I defined a variable, but I'm not yielding any values. So let's see what happens when we hit x0. And as you can see, Q2. So again, fall through happens. So the switch expression with the yield still follows the fall through behavior. Which means if for a given case you don't yield any value, basically obviously the first case that we match, the other cases become invisible, right? And then the runtime starts basically executing the lines of code after the other cases are invisible, unless we hit a yield. When we hit the yield, then it returns that value and then jumps out of the switch. So this yield plays like a break, or provides the same functionality of the break. So until we hit the first yield, we continue executing. And I can show you by saying that var x2 equals this. So I'm hitting case 0, right? My switch variable is 0, so I have to hit this, but I'm not yielding any value, so I'm not returning. So then case 1 also I'm not yielding, so eventually what I yield is case 2, right? This Q3, because when I match case 0, case 1, case 2, case 3 become invisible, only the lines of code are visible. So we expect in this case to hit Q3 or return Q3 as the yielded value for the switch. So be very careful. What about, can we allow to have a break here? The answer is no, it's not allowed. Break out of switch expression is not allowed. So you cannot break out of a switch expression using a break keyword. That's completely not allowed, because break doesn't return any value. Just remember that. So break statement does not return any value. We've seen that the break can accept an argument, right? But that argument is a label for a for loop or something. You want to break and jump to that particular label in your code, right? So have in mind that break statement does not return any value, and therefore the compilation error that we're getting is break out of switch expression not allowed, right? So have this in mind. You can never use break in the context of a switch expression. Okay, so the final how do we get rid of this? Okay, so the final topic in terms of switch expression is dealing with null values. We looked at this when we looked at the switch statement, null values. So far, switch statements do not accept null selector values. If you try to switch on a null value, you will get a null pointer exception. Java 17 has a preview feature that enhances switch expressions to allow for null values, so you can expect this situation to change. So right now JDK 17 is out, and it's a preview feature, which means it's not finalized yet. So if you want to use it, you have to manually give the JVM or launch your Java application with a extra flag to tell the JVM to unlock these features or be able to use these features. For now, it's always best to avoid null, and we saw that we can use wrapper types also. And then what if we set this to null? Then we get a compilation warning. So again, we don't get a compilation error, we get a compilation warning. Null pointer access. This expression of type integer is null but requires auto unboxing. So the compiler realizes that, hey, I mean, this is not a compilation error. That's just because null pointer exception is a runtime error, right? So if you run this, we're going to get a null pointer exceptions. Yeah, but because null pointer exception is a runtime error, not a checked exception, it's not a compile time error. What happens here is that basically the compiler doesn't give us a error. It gives us a warning which says, hey, if you run this code, you are getting a null pointer exception. I'm just warning you. It's on you, right? If you run this and you get null pointer exception, the only person to blame is you, not me. The compiler is warning us beforehand. All right. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.